What's up, world? Daniel Dallas is coming back, and I'm coming back with trigonometric identities. That's definitely first trigonometric identities and trigonometric topics. So, because the speech is all about double angle, we're gonna go through proofs and equations. So, finally, you'll encounter with how to solve equations. And for now, it's the best way to go through formulas that you need before starting rushing ahead and doing something until you solidly know which formulas to apply. All right, so that's the right time to understand which formula is going to be very useful, which formulas you can derive, because you cannot crash your mind and get all the formulas put it in your memory. Otherwise, you'll be definitely slowly to think, and be overloaded with tons and formulas is not a good idea. All right, so I'll give you the two basic formulas for the double angle, and also I'll show you how to use maybe for more complicated questions where you have to apply those concepts and need to know something more. So that's why we're going to start from, by definition, because the topic is all about double angle, we're going to start with two formulas that you definitely need to know. It's all about cos 2x and sine 2x. As you can see, 2x here and here, it's a double argument or a double angle. So that's why you need to know how to convert back into a single argument like sine x and cos x. For example, let's see how the first formula looks like. Cos 2x is going to be equal to cos squared x minus sine squared x. Okay, it's basically the difference of cos and sine function of the single argument. And because it's the difference of cos squared and sine squared, you can perceive as the quadratic, basically the square, the difference of two squares. So just remember, in comparison a squared minus b squared, you can always set up as the factorized form, like a minus b times a plus b. I think that's going to be useful somewhere, and that's why cos 2x can also be written as cos x minus sine x times, so you can times the sum of that, cos x and plus sine x. All right, but this formula you don't need to memorize because you can always do that, right? What about sine 2x? So you're gonna write in very similar way, except for using the formula of 2 sine x and cos x. What does it mean similar way? It means that you again come up with two functions which basically sine and cosine. However, the formula is a bit different. So here you have the product of sine and cos x, and you have coefficient 2. All right. So how you actually need to apply the formula? The idea is pretty straightforward. If you do have something like cos 2x, and you need to prove that on the right side that's going to be like something connected with sine x, obviously use cos 2x converting into the function of one argument. And how to work next? So every single student know those and can use from formula booklet, but still have like experienced troubles, or there might be some troubleshoots with how to work out next. And the next episode, if you have on the right side of the identity the very like single function like sine x, or the function where you have only one trigonometric function, again like sine x, like 1 minus sine squared, for example, or square root of 1 plus sine x squared. So again, make sure that you remember that trigonometric identity always works. So that means it's sine squared x plus cosine squared x. And you can re-express, for example, cos squared x if you don't need on the right side. For example, you can express cos squared x through sine. So that means finally, using cos 2x formula, you can actually derive several variations. For example, if you want to use only cos, so the right side involves only cos, so you can easily do that because 1 minus sine squared x is you express cos through sine, but because you need only cos x, you can express vice versa, sine squared x as 1 minus cos squared x. Okay, so you understand that using trigonometric identity, you can always figure out just one trigonometric function through another one. Okay, and because you want to have only cos x on the right side, so that's going to be cos 2x equals to, let's just plug it into the formula. Instead of sine squared x, we plug in the right side, and that's going to be cos squared x and minus 1 and plus cos squared x. So in other words, you basically double cos squared x, and you can erase this one. And you get variation that on the right side contains only cos x, where it might be useful, for example, like in this case. However, in this case, you want to stay with sine x on the right side, so that's why it's better to express cos squared x through sine, okay? So that means if you plug again to cos 2x, so you can rewrite cos 2x through sine as 1 minus 2 sine squared. And actually right now you have the function of one trigonometric function sine x, okay? So that's probably be very helpful. Again, when you're going to prove some identities using double angle formulas, so make sure you understand that what you have on the right side. If you do have on the right side only one trigonometric function, this is the straight way just to re-express everything through that function. Like if you see that on the right side stays sine x, just make sure you re-express cos through sine using again trigonometric identity. I mean, this main formula that actually comes back in days long ago when you start actually learning the basic trigonometry, okay? Maybe it comes from year 1, I guess. All right, so I hope you understand how this works, and vice versa. If you do have sine x and finally you want to come back to the cos 2x, so make sure you'll get something quadratic and just re-express through cos 2x then. All right, so that's the main idea. And as you can see, you can have like plenty of variations for the first formula, and maybe less flexibility the second formula has because it re-expresses only sine of the double argument through 2 sine x and cos x, okay, as the products. So that's why it's less likely that you'll be going to express sine through cos. However, that might be also the case because, for example, using trigonometric identity, you can say that sine x is plus minus square root of 1 minus cos squared x. So that might be the case, and you can always plug in. However, working with surds is not very efficient, and probably you lose your time. So just less likely do that and try to find the other way around. Okay. So I think that's enough for useful formulas. However, again, there might be more complicated question involving not just double angle, but probably involving the 4 times the angle. For example, let's consider this simple example. It's actually not really simple, but it again involves double angle formulas. So for example, the question might sounds like express cos 4x. Say express cos 4x through sine x and cosine x. So for example, through cos x first. Okay, so in part A we'll consider through cos x, and in B part we will consider how to express through sine x. Okay, because it involves actually the angle x times 4 times greater. It means that you can every time express as the double angle. So 2 times alpha, where alpha is 2x. So basically it's going to be like 2 alpha, where alpha in its turn is going to be 2x. And you still be able to apply the formula. All right, so let's see. It's going to be, by definition, cos squared of 2 alpha, of alpha, of course, minus sine squared of alpha. And instead of alpha, you still can use 2x. So that's why you'll get cos squared of 2x minus sine squared of 2x again. Because your primary goal is to express through cosx, you again need to apply the formula. But the problem is that if you apply the formula for sine 2x, you'll get just maybe not very good way, because sine 2x is going to be 2 sine x cosine x, and then you need to again raise to the power of 2 and express sine squared x through cos x. Okay, so that's why it's more efficient first to stay with one trigonometric function, in this case sine squared 2x expressed through trigonometric identity. So how you can do, because you're not restricted in trigonometric identity of the values of your angles. Angle might be any, so that's why you can easily write for a double argument the same trigonometric formula, cos squared of 2x, because you're not specifying which angle you need to use. It can be any actually. In this case, let it be 2x. It's not a problem at all. From here, because you want to stay with cos x, so let's express sine squared from here. So sine squared of 2x is going to be equal 1 minus cos squared 2x. And right now, if you plug in here, so just let's do that. Cos 4x is going to be equal to cos squared and minus cos squared again. But because of minus sign, you'll get minus times minus is going to be plus. So finally, and eventually, you come up with this. 2 cos squared of 2x and minus 1, right? So basically, we apply this variation. Where is this variation? Let's see. It's going to be that one. Cos 2x is going to be 2 cos squared x minus 1. So, but we've got for cos 4x, so that's why we'll get cos squared 2x minus 1. Okay, now, as you understand, we reduced the argument 2 times, right? So 2 times less. In this case, we left with that one, and we can again apply the formula. So cos squared 2x is basically 2 times, and right now I'm just express cos 2x. So cos 2x by definition is cos squared x minus sine squared x, or again, because we want to stay with cos x only, we'll get 2 cos squared x minus 1, and that's going to be in the brackets and squared because you have square here. So that's the square and that's the square, okay? So that's why you just square up this expression. That, as you can see, you left with cos function. And finally, you take away 1, okay? So finally, cos 4x is going to be equal, now you just need to raise to the power of 2 and also expand the brackets, but I'll do step by step. So it's going to be like 4 cos 4x, then it's going to be minus 4 cos squared x and plus 1. So again, I'm just using the formula of square of the difference a minus b, so a minus b squared, and take away 1. And finally, if you expand the brackets, you'll get the final expression as 8 cos to the power 4x minus 8 cos squared x, and in the end, you need to plus 2 and minus 1 is going to be plus 1 finally. Alright, so we've got expression for cos for x, and we completely express cos for x through cos functions, as you can see here and as the question required to do. Alright, so in the same analogy, you can try to express through sine x. Try to do by round, it's not really hard. The principle stays the same, except for you need to express everything through sine x. Alright, so I think that that's enough in terms of formulas, okay? So make sure again you remember those basic ones, okay? That's kind of basic formulas, and everything in the rest, as the rest part, is going to be just basically derivative formulas from there. Okay, don't mix up with differentiation. I mean, you can derive this formula every time you need, okay? And this skill is very valuable and that in high demand when you're trying to approach to solve trigonometric identities, like you're trying to prove or do something with trigs, trigonometric equations, like you're trying to solve that. So that skills to derive formulas in different and making different rearrangements is very valuable, trust me. All right, so I think well done with the formulas. Again, make sure you understand how this works. This you can consider as the footnotes for you. And we're gonna go to the problem, okay? Here is the problem 1, but before we go on to the problem 1, just please consider the subscription to my dance channel. It's all about dance. You can find different style and techniques from breaking up to animation style and up to top rock. So consider a short trailer. It's gotta be enjoyable. Let's watch.